All right, today in class we talked about graphing absolute value equations, and to help you with your homework, numbers 1 through 9 are very similar to the way we did things in class, but then on numbers 19 through 27 they ask you to graph each equation by writing two linear equations. And I just realized that I probably should have sent you guys two graphs so you have enough pieces of graph to graph every assignment or every problem, but maybe you can graph two on each graph or just graph them separately. But what I'm interested in for numbers 19 through 27 are, can you write these equations with two separate linear equations? And I'm going to go through this tomorrow in class as well, but I'm going to pick out number 20 so you can take a look at this and see if there's a way that you can get it all figured out before tomorrow even begins. So number 20 looks like this. If we were to do it the way that we would do numbers 1 through 9, first thing we'd ask ourselves is, how do we get the vertex? And the vertex, remember, negative b over m is going to be negative 6 over 3, which is negative 2. And there isn't a c value here, so it would just be negative 2, 0. That's the vertex that we would have. And then we would ask ourselves whether it opens up or down. The absolute value is positive, so it's going to open up. It's going to open up, and then we want to know what the slopes are. And the slopes are plus or minus a times m. That's 1 times 3. So the slopes are going to be plus or minus 3. We're going to come back to this here in a little bit once we get done writing the two separate equations. Well, if I were to separate this and write it as two separate equations, one equation would just be y equals 3x plus 6. We could write a separate equation here. We could say 3x plus 6 equals negative y, or I can just say y equals negative 3x minus 6. In other words, I can make this part negative. If I did it the other way around and had 3x plus 6 equals negative y, I can go from this step to this step simply by multiplying both sides by negative 1. And so they really are the same thing. Regardless, though, here are my two linear equations. Y equals 3x plus 6 and y equals negative 3x minus 6. And if I'm going to graph these two things, the first one has a y-intercept at 1, 2, 3, 4, 5, 6, and a slope of 3, which means if I start here, I'm going to go down, I'm going to go up 3 and to the right 1, or I'm going to go down 1, 2, 3 and to the left 1. Down 1, 2, 3 and to the left 1, which means I'm going to have an equation or a line that looks like this. With this one, the y-intercept is at negative 1, 2, 3, 4, 5, 6, which is down here, and the slope is negative 3. So I would go down 3 and over 1, or I could go up 1, 2, 3 and left 1, up 1, 2, 3 and left 1, and I'd get a graph that looks like this. And you can see our vertex is where we thought it would be at the point negative 2, 0. And the slopes are positive 3 and negative 3. And this particular graph, because the absolute value is positive, opens in the positive direction, which means my graph would end up looking like that. And my two equations would be these two equations here. That's number 20. Number 20 is very similar to 19 through 23. They get a little bit more difficult after that, but I'm going to save the others for tomorrow. I'd like for you to do your best, and we will see everybody tomorrow.